I was in doubt if they had turned it down or that I had to start yelling. Sorry, I was muted apparently. Welcome everybody. Thank you for making it to this room. It's my pleasure to talk to you for the next 45 minutes or so about secret management. How are we going to deal with secrets in our configuration while developing locally, but mostly while doing deployments? Now, I'm not going to present to you the one true solution. I will try to offer you a whole set of opportunities, alternatives that you can use, so you can pick and choose what you want, what you need, and what works in your situation. So before I start, you might be wondering, who's that weird blonde guy up there? So hi, my name is Henry. I'm a developer and architect from the Netherlands. I actually live on one of the islands in the Netherlands, so I'm used to traveling. However, going to Moscow has been quite the ride for me, so I'm really, really excited to be here. Thank you for the invitation. I will be at the conference for a couple of hours more after my talk, so feel free to find me if you have any questions, comments, criticism, maybe compliments, but mainly criticism, of course. And you can also find me on LinkedIn, Twitter, or even the old-fashioned email if you would like to do so. So now, before I start, I would like to get a little bit of a feel for the group here. So who is thinking he is practicing DevOps already here in the room? Okay, so that's roughly half of the people. And who's a developer in here? A programmer. Okay, so 1/3. And IT pros, DevOps engineers, pipeline automators. Okay, so what else do we have in the room? Anyone who wants to speak up? Any other roles? Managers? Architects? Sorry? Teachers. Oh, okay, so I will do my best. The reason I'm asking this is because this is kind of why I created this talk, why I dove into this topic, I think, a couple of years ago, because I needed to learn a number of things myself, being a developer. Because this is like very simplistic, the development process that we're used to. And what I was taught is that we had this split between what developers do and what operators do. And I have been focusing only on development for a while. And only later on, I had to learn about operational things, to do some operational things myself, do deployments myself, but also to interact with other operators. So I think now that we're doing DevOps, being a developer, I also need to learn about operational things. If it is not to do things myself, it is to at least have a decent conversation with the guy or girl going to do the deployment for me and work together. So that's the reason that I created this talk. And I think also the reason that all developers need to learn more about operational things. So what I hope to accomplish during this session is to give you the means to accomplish a number of goals related to secret management. For example, this very simple first one, no secrets in source control. Now, I am happy to admit on stage, even on camera, that I have made this mistake. It is very hard to have a file in your sources directory and not accidentally check it in. Now, I'm not going to ask you to raise hands. I don't want anyone to get in trouble. But I think if we look at ourselves, we can all admit that we have done it at one or two occasions, accidentally. So let's see if we can find means to prevent that from happening. Secondly, we want to try and create a situation where it is easy to change our secrets and to change them frequently, for example, every month. We want to try and create a solution where we don't need secret sharing or secret passing. Especially in the past, when a system administrator created the username and the password for me to use, he had to get it to me in one way or another, and I had to store it securely. Now, even assuming that that second part is okay, this transferring of secrets in many companies is very interesting. It's not going on Post-its probably, but it might be going through email, Skype, Teams, Slack, I don't know, whatever, at least not the most secure means. So that's the thing that we're going to try and avoid as well. And finally, this whole thing with secrets is just a pain in the backside. So if we can get rid of it altogether, that would be really awesome. So we're going to try and see if we can achieve that as well. However, before we go to what we can do, it is always good to take a look at some things that we might better not do. Not to laugh about it, but to learn from it. So the first thing that I don't like is this really enterprisey approach of trying to make it somebody else's problem. Just let operations deploy, have our own development time secrets, and forget about the whole problem. Another thing that I would recommend. Another thing is, enter your secrets manually in your configuration. That can be in the Azure portal, that can be in an AWS thingy, it can be in IaaS, wherever. Doing secret management manually, not a place you want to be, I think. Mistakes will happen, secrets will be leaked. Another thing that I see people do is encrypt their secrets and store them in source control. A colleague of mine phrased it very, very good 2-3 weeks ago. He said, a secret which is encrypted is still a secret. And if you have those in source control and people get your sources 2 weeks, 4 weeks, 8 weeks, 20 weeks later, they get your key one way or another, you can change that key all you want, but they can use that key to decrypt the secret they already have encrypted for a while. So not necessarily the best approach. Another problem with this is that you're often going to use a different key for production than all the other environments. So what I've seen a couple of times is that people only update all the secrets except for production. So everything appears to be working, and then you go to production, and everything stops working because secrets for production weren't updated. And this is a thing that once somebody shared with me, and that I wanted to point out, is we are going to create a use once HTTPS endpoint to create our secrets. This was a home-built solution for secret management. Now you might be wondering, what is that? So I had that same question, and I asked him, what is this? What do you mean by that? So he said, we're going to create an HTTPS point, foo.bar/secrets, and we're going to have our application at startup do a GET request. And it's going to give us back all the secrets. It's HTTPS, so that's secure. And to prevent other people from calling that same endpoint, we're going to make it work only once. And we're going to have our application throw an exception whenever it cannot load the secrets. Now that's a thing you can do. And then when we deploy, we're going to reset that, only give it once counter. And then our new version can pick up the secrets just once and nobody else can again. Why do I show this? I use this to point out that very good secret management is hard. Now, over the last couple of years, good tools have become available, and we'll get to them in a couple of minutes. But these are the kind of homegrown solutions that people came up with in the past to tackle this problem. And that is because it is a hard problem. And to illustrate that, I want to share a very short story with you. It's about a man and a woman that are talking about, philosophy, where the world came from, how the world is. And that woman said to the man, I firmly believe that the whole world is sitting on the back of a turtle. And that man, instead of ridiculing that woman, was very seriously interested and said, that's very interesting, but can you please tell me what that turtle is standing on? And the woman said, sure, of course, that's very easy. That turtle is standing on the back of just another, much bigger turtle. Interesting, said the man. But where is that second turtle standing on? And then the woman said, I know where you're going, but don't worry, it's turtles all the way down. And the question is, all the way down to where? Where does it stop? Now, if we go back to secret management, this is the problem that we often encounter with secret management as well. We have a number of things that we want to keep secret, passwords, keys, etc., and we put them in a store, in a key vault, in a CyberArk thingy, in a AHM, whatever. But what do we get when we have all those secrets in that store? We get one secret to go to the other secrets. Now, where do we store that secret? We're going to put it in another safe, and what do we get in return? Yet another secret. So this is the difficulty of secret management. Now that we have clouds, now that we have powerful platforms that we can build upon, we can use those platforms to prevent going all the way down, turtle after turtle, safe after safe. So let's take a look at what we can do then. And the rest of this talk is going to be a very curvy, long road across a number of approaches that we can take for secret management. And like I said, it's not my goal to share with you the one true way of doing secret management. I want to give you a toolbox of things that you can use working in your own companies, things that you hopefully can apply tomorrow. So without further ado, let's dive straight into the first one. So this relates to a type of deployment of secrets that we can use. And this sounds like cheating maybe a little bit, because you're probably used to this already. What we're doing, we have our code, we have it in source control, and from the code we run a build pipeline, and then a release pipeline, and Azure DevOps. And instead of having the secrets in source control, we're going to store the secrets directly in Azure DevOps. And just before we deploy our binaries, we're going to add those secrets to the binaries that we're going to deploy. So let's take a look at how that might look. And to do that, I am first going to introduce a very simple application that I've created to demonstrate a number of things. So a lot of presenters, they create very elaborate demos, but I'm a cheater. So what I did file, new project, ASP.NET Core. Then I removed all the HTML, except for a very small part. Here we go, it's finally running. And I created an application that looks like this. What it does, it gets a secret from configuration and it displays it on the screen. A thing we all do from time to time. Of course, we're going to focus on how that secret gets on the screen. So in this instance, what you see is maybe not the secret that you're expecting. Because in my configuration, it says you shouldn't keep secrets here. And this is a file that is stored in source control. Just to make sure, this is the development addendum. It's not containing my actual secret as well. What I instead have done, I've gone to my project, and I have right-clicked it, and then there is a thing called Manage User Secrets here. What this does, it will generate a GUID, which it attaches to your CS profile, and then with that GUID, it creates a new file, secrets.json, on a completely other location on your file system. And here you can store your secrets. In Linux, it's going to be /home/username/.something, at least a place that only your user can access. And on Windows, it's going to be c-users Henry Bin /something that only I can access. So now they are completely separated from my sources directly, and I can no longer accidentally check them in. So this is the first thing that I wanted to show you, and this relates to secrets locally and how you can separate those in a very, very secure way. Now, one thing I want to point out as well is, please note that I do have the key of the secret in here. And that's on purpose, because whenever somebody new joins the team, now they at least know which secrets they have to set and which secrets they have to get, instead of running from runtime exception to runtime exception. To see if a project has user secrets enabled, we can go to the CS Pro, and here we can just find that GUID. As you can see, I just wanted to quickly point out, I am doing nothing special in either my program or my startup to load these secrets. This is completely built into the new ASP.NET Core stuff from 2.2 and forward. Now switching to deployment time, which is where we're going to spend the rest of our time, I have created an existing app service, an app service plan, which is kind of the hosted IIS within Azure, where I'm going to deploy my code to. So what I've done, I've created a pipeline in Azure DevOps, just for curiosity. Who is using Azure DevOps to create these applications? Okay, so I'm going to spend 2 minutes on how this thing works. Azure DevOps, it's a complete DevOps ALM suite offered by Microsoft. And it contains source control, it contains build pipelines, deployment pipelines, release pipelines, package management, and you can also write test plans in there. So the first thing that I've done is I have created a build pipeline. And it is called secrets.releaseorchestrator. And what this pipeline do, it just restores NuGet packages on my solution, it compiles the solution, runs my tests, there are none, shame on me, and then I publish the ASP.NET project to a separate folder, a staging directory, from where I package it and publish it as a build artifact. Now next, I have created a release. So a release picks up a build artifact and can deploy it to one or more environments. And such an environment we call a stage. So in this specific instance, I have my artifact coming from my build pipeline, and I'm using that in one stage with the awesome name of stage 1. And this is where I'm going to deploy that to the app service that I've shown you before. Now there is a built-in task for doing that deployment. It's called the deploy Azure app service. And what I do, I point to my zip file, which contains my app service. But this thing has one override option, and that is for the app settings that the application should use. And here you can see that I'm overriding the value of dsecret with kind of a weird thingy. This is the parameter notation, variable notation in Azure DevOps. Here I am referring back to one of the variables that I've configured for this release pipeline. And this is where we're going to change from security to trust. Here I'm trusting that Microsoft will keep this value safe. And I feel my trust is not misplaced, because when I try to show this value, it's not coming out. They are going to store it securely. And this is the easiest way of doing secure deployments. We have separated our secrets for local development, and we are also separating them out for runtime deployments. However, this is far from perfect. There are a number of problems here. First of all, we have to get the secrets first, and we have to enter them in Azure DevOps, so we can see them, and we copy them somewhere else. Also, once I've done this deployment, I can go into the Azure portal, and I can just look the secrets up in the configuration of the app service. I am doing duplication of secrets. It is both at the source and in Azure DevOps. And changing secrets is a bit of a pain in the backside. Why? Because I have to go through this whole process. I have to have at least a primary and a secondary secret. So 2 keys that both can be used. This is the reason you get 2 keys with a storage account or a cognitive services account or all these things in Azure. Because what I have to do is I have to change the secret in my release orchestrator to the secondary secret, then do a release. So now I'm using the secondary secret. Then I change the primary secret. I roll it. Then I use that again in my release orchestrator, do a new release, and then roll the secondary secret. Now both my secrets have changed, and I have had no downtime. But this is kind of a nasty procedure. So let's see if we can avoid that. So let's try another approach to secret management. And here we're going to use the fact that I think when moving into DevOps, we're not going to just continuously deploy our code. We're also going to try to do continuous deployment of our infrastructure. And within Azure, you can do that using ARM templates, Azure Resource Manager templates. Here I can describe the complete infrastructure that I need to run on, and I can also insert the configuration of my app service, for example. Now, we can use that to get our secrets to our application in another way. So let's take a look at that. And you might be wondering, why do I keep using this image? I paid for this image. So I am Dutch, and I will use that as much as possible. Here I have created a new resource group in Azure, where I still have an app service and an app service plan. But as you can see, I now also have a storage account and a key vault. So who is not familiar with Azure Key Vault? Okay. Who is using Azure Key Vault in production? Okay, just the one. So let's do a very, very quick tour of the Key Vault. The Key Vault is an offering within Azure that I can use to securely store secrets. I can put them in, they are versioned, they are backed up, and every time when somebody sets a secret, it's not overwritten, a new version is created, I get an audit log of who accesses the secrets. It's really intended as a secret store. It's more than just simple configuration. Now, it kind of does what you expect. I have an option secret in the menu for my key vault, and it lists the secrets that I have. I have something called dsecret. What I can also do is set access policy. Here I can define per user which authorizations you have. So I can even give some users only the means to update secrets and not see them, and other users only the means to get secrets and not use them. So for example, developers and operators have the right to put in secrets, but they cannot retrieve them. Only my deployment orchestrator can retrieve secrets. So I can do very, very good separation of authorizations. So that's what I can do using Azure Key Vault. Now what I have done, I have created an ARM template that creates the infrastructure that my application needs. So this is a pretty big JSON file, and I think there have been talks and actually even a workshop on infrastructure as code by Michael yesterday and the day before yesterday. So what I'm doing here, I'm specifying a number of resources in Azure. First of all, I am creating a storage account, which I'm not using at runtime. I'm only going to use it to show something to you. Then I'm creating a server farm, which is the resource name for an app service plan. on that app service plan, I'm going to create an app service. And within that app service, I have one more resource, which is my configuration. And what you can see here is that I'm specifying two secrets, dsecret again, and a storage key secret. So let's take a look at the second one first. What I'm doing here, I'm using this syntax to query the storage account that I've created before for its access key and insert that value. So the storage account key is never leaving Azure. I am not seeing it. It is going directly from the storage account into the settings of my app service. Pretty neat. Now the secret is something that I have to specify from the outside. So I cannot refer some other resource. Here I am picking it up from the parameters of my ARM template. So I'm declaring it at the top that I need to receive it. It should be a string. Now with such a template, I can create one or more parameter files that specify the actual values. Now these files are in source control. So I am not going to insert the value of that secret directly. Instead, I'm going to reference the key vault that I created earlier where the secret is stored. And as long as the one that is deploying this template has access to the key vault, this deployment will succeed. And I will not see the secret, I will not have it in my hands. So to do that, I have created a new deployment pipeline. And instead of just deploying my code, which is this step, and just to show you that I'm not cheating, I am not updating any configuration settings here. But before I do that step, I am going to deploy my ARM template to an Azure resource group. And this creates the resources I need and also updates the configuration as I need it. And in case you're wondering if I'm cheating here as well, if I refresh this thing, you will see that we now get a secret from key vault. So this is fetched at deployment time of my infrastructure and inserted into the configuration. Now, is this solution perfect? No, this solution is not perfect. First of all, secrets are still visible in the portal, just as they were with solution 1. And changing secrets is still a bit of a pain in the backside. I have to go through this whole redeployment thing to update my settings, which is not nice. So let's see if we can improve upon this one as well. Because when we start thinking about it, isn't it kind of weird that we store our secrets in a key vault and then pick them up only when we're doing a deployment? Wouldn't it be much nicer if we could configure our application to go to the key vault itself? Makes sense, I hope. However, that puts us in another problem. How is the application going to prove that it has the right to access that key vault? We could give that application a username and a password, but then we have two new secrets that we have to store somewhere. So this is turtles all the way down again. Now here we can again switch to the platform for a solution. Within Azure, but there are also similar offerings available at least in AWS, there are means to give an identity to my application and use the platform to authenticate and prove that I am running as that application. In Azure it is called managed identity. And what managed identity allows me to do, it's actually a string I update on my ARM template or checkbox in the portal. It's going to create a service principal in the Active Directory. And through my app side, it's going to provide two more environment variables that I can use for authentication. And once I'm authenticated, I can go to the key vault and retrieve the secrets that I need. Now that's really cool. However, this will only work in Azure, this managed identity. It will not work anymore when I'm working locally, when I'm debugging on my own machine. So I have to find another solution for there. So the first solution is that I can also give my developer account access to the key vault. Now this is a very decent alternative, but it will require you to log into Visual Studio with that account so that your identity can be used to go to the key vault when you start a debugging session. If you're not working with Visual Studio, you're using another platform, this is kind of hard. So another alternative is to only use the key vault when you're working in Azure. And when you're working locally, you're just going to continue using your user secrets. And the third thing that you can do is you can also create an extra identity in your Active Directory and give that identity access to the key vault, and then create a username and a password or a certificate to authenticate as that identity and distribute that to all your developers. Now the downside is that this shared identity is not really an identity, because you're going to share it with multiple people. And of course, if you're using username and password, you have to make sure that you do not check those into source control again. And if you're using certificates, you have to make sure that you distribute them to everybody, install them in the certificate store. I don't know if that's going to work on Linux. So there are some downsides there as well. So I have chosen for option 2, especially since that's built into the .NET Core framework now. So let's take a look at the changes that I've made to my application to make this work. The first thing I have done is I've gone to my ARM template and I've added this thing to the definition of my app service. Identity of type system assigned. This will generate the service principal that I was talking about earlier. But this service principal does not get access to the key vault by default or for free. So I have added the key vault to my ARM template as well. And within that template, I can also specify one or more access policy that I want created on this ARM template. Now I'm giving the identity that I created before only get and list, so it cannot accidentally change the secrets. And again, I'm going to use an expression to reference the app service, and from that, a lot of more expression, in the end get the principal ID. This is the object ID in the Active Directory that I need to authorize on this key vault. Now this expression, you can look it up on the internet. It's on my GitHub, so no need to try and memorize it. This sets up the authentication and authorization. However, I also have to configure this. So this is the first time I have to change the startup of my program a little bit. First of all, I have installed a NuGet package, which is called Microsoft.keyvault.app authentication, something like that. And I'm inserting this code. I am adding a token provider, which can authenticate against the Active Directory. And I'm using a built-in callback to go to the environment variables and do the authentication. And then I'm going to load the secrets from the key vault name that is in my configuration. So instead of inserting the secret, as I did before, I'm only inserting the name of the key vault. And this will, at startup, load the secrets that I need. So if I demo this, you will see that this page will refresh and it will still say, welcome, I'm going to share you a secret and my current value. Now, but this solution solves one of the downsides, and that is the difficulty of changing secrets. Because if I go to the key vault that is hosting this secret, and I find the secret, I'm going to say add a new version, and I'm going to type something very secret. And now I add this. Now I'm going to my app service. And what I will do, I will stop it. Then I will do 21, 22, 23, 24, and now I will start it again. So I'm forcing it to go through the startup routine again. And if I now go back to this side and I refresh it, we will see the new secret. Now, of course, this starting and stopping is not really neat, but it's very easy to change your program startup to also include an automatic refresh of the secrets whenever an existing secret doesn't work anymore. So this is a pretty big step forward from what we have seen before. There's only one downside left, really, and that is that it's only going to work on supported services. Now, the list has been growing over the last year and a half, and it is still growing. Right now, app service, virtual machine skill sets, data factory, all support managed identity. But if you're running on, I don't know, the old cloud services, this is not going to work, for example. But if we take this approach and we think about it, we now have an identity in our application, and we use that identity to retrieve secrets to go to another service. If we really think about it, wouldn't it be much cooler if we could just skip the whole key vault thingy and use our proven identity to go to the service directly? This is a problem that we have solved already for people. We're using authentication with Twitter and Google and LinkedIn all the time to go to another service. And we can apply this practice to applications as well. So let's take a look at what that would like. So this is the final solution that I'm going to show to you. And what I'm doing here is I am working with an Azure SQL Server and database. So I have added to my template the definition for a SQL Server. And on that SQL Server, I'm first of all creating a firewall rule so that I can access that server whenever I'm running in Azure. I'm creating a database because a server without a database doesn't have much use. And finally, I'm setting up an administrator account. Now, this can be a username or password combination, but we want to get rid of those. So what I'm doing instead, I am setting what is called an Active Directory administrator. Now, again, I'm going to reference the object ID of the managed identity I created earlier and give that access to the database. Now, one thing you might notice, which is a bit weird, is that I'm specifying also a login, and doesn't really matter. I have to specify a display name for the identity as well, but I don't know it, and it doesn't really matter what I put in, but if I leave it out, the thing is going to crash. So this is the trick that I use. How do I use this when connecting to Azure? Because now I cannot go to my configuration anymore to get a connection string. I have to change my code to do this. So this is my code. I'm going to build up a SQL connection. I think we, as C# developers, know it. And I'm going to my configuration to get the connection string. This is locally also containing a username and a password. But when running in the cloud, I am not inserting the username and the password. Instead, when I detect that I'm running as a managed service identity, I'm again using my token provider and retrieving a token, in this case for a specific scope, database.windows.net, and I'm putting that access token on the connection. And now I can just open the connection. I do not have to specify a username and password when running in the cloud. Now this will work on .NET Core and .NET Framework 4.7.1 and up. So you have to be on a pretty recent version of either to work with this. And after that, I can just connect to the database, do a query. And to show you that this actually works, this is the running demo. This is going to the database. It's going to a table called secrets, because we're working with secrets, and it's retrieving just another secret from the table. And to show you that I'm not cheating, these are the resources that I have in Azure. There is no key vault anymore. There is no place where I'm storing configuration. I can even show you the app service. Go to the configuration, and you will see there are no key values specified for connecting to the database. Because if I open this one up in detail, we will see there are a number of configuration entries here, but no username and no password. Reflecting back on this, this is awesome. We don't have secrets anymore. If we don't have them, we cannot lose them. We cannot screw things up. It's pretty awesome. The thing is, this is supported on even fewer services, because we're using managed identity, but the service that we're connecting to also has to support OAuth-based authentication. So in Azure right now, these are some of the services that support it. So ARM itself, the key vault, SQLDB I've shown you, and the list is growing, and there is a link to the list of services that support OAuth authentication that I will share later on. Doing a quick recap. What to use when. So first of all, try and make it somebody else's problem, or do things manually. Another thing that I would recommend. Using your release orchestrator. This is probably what you're going to use when you are stuck deploying to existing infrastructure, when somebody else creates the app service that you have to deploy to, when you're deploying to a fixed IIS service that you are not allowed to touch from the administrator, then you're probably going to be stuck with this one. But if you are in control of the infrastructure and you're using infrastructure as code, you're going to probably try and use the infrastructure and configuration management system that is provided by your cloud vendor, or even your on-premises stuff. Try and use managed identity and key vault whenever available and possible. Try use OAuth whenever available. Now, one of the things you might be wondering about, this is all .NET Core 2.2 and forward. what if I'm not there? What if I'm using all this stuff? What are things that I can do? There are two more things that I wanted to share with you. First of all, the key vault reference. This is more recently become available in Azure, and what it allows you to do is you create a managed identity on Azure. So you are deploying to an app service, but it might be framework 4.5 vanilla code. Now you give that managed identity access to the key vault. Still no changes in your code. And instead of providing actual values in the configuration, you're going to use this syntax. This is a new thing, and when you work at Microsoft and you create a new thing, you have to invent a new syntax. So this is the syntax that you're going to use to reference a specific version of the secret that you want to use. Now we're not having the secret in the configuration anymore, and we haven't touched the code. There's just one downside, and that is if the secret changes, I have to update this value to the latest version. Now until yesterday, there was an unsupported alternative to leave the secret out, a secret version out, and it will work, but it's not supported. It's not a thing that they were intended to remove. And just this morning, I read a tweet from an old colleague of mine that this is now also supported, but I haven't verified it yet. So please be careful when using this approach. And of course, if it works, the advantage is that it will always default to the latest version of the secret. Also very recently added is a new Azure offering which is called App Configuration. Here you can store configuration, including secrets, and connect from your application to that configuration store and fetch the configuration you need. And you're going to use a connection string, basically a location and a key to get to that configuration store. Now this is really cool. If you have, I don't know, 20 services, let's call them microservices because that's sexy and hip, and you have a lot of shared configuration, you can use one place for your location and have all the applications fetch what they need instead of having to distribute it to all the different apps. If you take a look at how this works, we have this app configuration, we're going to load it over HTTP from our application at startup. Now we're not going to use this use once thingy, we're just going to use a proper key. However, my question is, where are we going to store the key? And thinking about it, it's like, yes sir, it is turtles all the way down again. So that's a problem that I haven't solved yet for app configuration. Maybe you can. Maybe we'll see you speaking here next time. However, this is where my story regarding configuration and secrets kind of ends for now. Except for this final thing. If you're doing all this and you're trying to keep secrets out of source control, maybe you want to verify that there are no secrets in source control. So last week I was on a call with Microsoft, and they have now made generally available the Microsoft Security Static Analysis tools. This is a task that you can download and install into your build pipeline, and it will automatically check everything there to ensure there are no secrets. And if there are, it will fail you build. So yes, your secrets are compromised, but at least you know. So that's an improvement. Now, this is not completely free. You will need a support plan with Microsoft to get to use this, and they are working on other options to acquire this as well. But it's a great addition if you are currently buying support. Really, this is where I want to stop. Thank you for your attention. Do try this at home. And if there are any questions, this is like the best time. Feel free to stand up, speak up. I think there is a microphone circulating, and I will now be switching to Slido to see if there are any questions there. Thank you. You're welcome. I will publish my slides on my LinkedIn and my Twitter, so find me there. And I will probably also upload all the code to GitHub. That will probably be in December when I have a little bit more time. I just have to make sure there are no real secrets before I push it from my private repos up to GitHub, because it would be kind of funny if I would mess that one up myself. Are there any other questions in the room?
Hello.
Hi.
Thank you for presentation. I have several questions, if you don't mind. First of all,
I have time.
First of all, do you use one key vault or you use dedicated key vault for several applications?
I personally always use one key vault for one application. So it might be that I have two APIs or two app services using the same key vault, but it's about segregation, because there is currently no means for setting an access policy to a group of secrets. So if I give you access to my key vault, you can either get everything or nothing. So I'm using key vault instances for segregation of authorization.
Okay, get it. Another question, how to back up key vault and how to save it from accidental removing or some disaster scenarios?
Okay, so the question is, I'm just repeating the question. I don't know if this microphone is recorded as well. The question is, how do you prevent somebody from removing the key vault or removing secrets that you still need,
yes.
Right?
Not
so,
preventing, but preventing and backup, how to be sure that you can restore it.
So prevention and fixing it once a problem.
Yes.
So you can do very fine-grained authorizations within Azure on resources. This is called role-based access control. So you can say, for example, you are only a reader of resources in this resource group, so you can see stuff, but you cannot delete stuff or update stuff. Another thing that you can use is you can add resource logs to your resources or resource groups. So people will get a notification, this cannot be removed, and then they first have to have the rights to remove the log, and then they can remove the actual thing. So this is about prevention. And there is also built-in control for backing up secrets and in key vaults. So this is not a thing I have personal experience with, but it's possible. You can go to a key vault and then do a backup. So let's see if I can very quickly point that out to you. I think it's on a separate, I have to go to a secret, and I can download a backup of this thing. So I can even take it out of the cloud and store it in this old system.
Well, I didn't know, thank you. And the last question, how to replicate key vault? For example, I need disaster recovery scenario, one region and another region, and I need to be sure if one region is down, I can start my application in the second region. How to replicate secrets between the region?
So the question is, how would I replicate secrets from one region or one key vault to another region with another key vault? By my knowledge, there is no building capability for this in key vault. It will be a really interesting ask to forward to Microsoft. But I think you have to take a look at your very specific application infrastructure to see if you need it. For example, if you're running in a DR scenario, you might be running two databases with two different sets of passwords in for, I don't know, your blue region and your red region. So maybe you do not want to share all the secrets back and forth. Maybe you have local secrets in the two key vaults. But if you have to connect to third-party things, you have to distribute one secret to two key vaults. I would probably build that into my deployment pipeline myself. But I think the best answer is, it depends.
Okay, thank you.
You're welcome. Are there any other questions? In that case, thank you for your attention, and have a great lunch.